Okay, welcome to another episode of Practice Help on Geometry with Mr. H. This is for lesson 1.5. This one's talking about symmetry, and this is primarily dealing with reflection symmetry, right? Where you can reflect something and it ends up in the same position as it did before. Okay, for each figure, identify any lines of symmetry the figure has. So if I put a line on this thing, and I would advise you use this tool here, the line tool, to actually put those lines on the diagram. Figure out where, if you slice this thing and then reflected it, everything would look exactly the way it does now. Okay? And if you can't figure that out, if there isn't a situation, just write, this one doesn't have it. Use the text tool and be like, this one doesn't have any lines of symmetry. Okay. All right. So same thing here. Are there any lines of symmetry? Once again, use the line tool right here. Okay. Use the line tool to draw some lines of symmetry on the thing. And there you go. Okay. How about this one? Lines of symmetry. Again, use the line tool, draw the lines of symmetry. Okay? If it doesn't have any, again, just use the text tool and say this one doesn't have any, blah, blah, blah. All right. Okay. In quadrilateral BADC, right? AB equals AD. So AB is equal to AD. Okay, so these two sides are the same length, and BC equals DC. BC and DC are the same length. Okay, great. The line AC is a line of symmetry for this quadrilateral. Okay, so a line of symmetry. That means that this line here is a line of symmetry for this quadrilateral. Okay, great. All right, so based on the line of symmetry, explain why the diagonals of AC and BD are perpendicular. All right, so why is it? Okay, so they're saying AC and BD. Okay, so if I draw another line here, right, B, from B to D, why is it that these things, why is it that those line segments, those diagonals, are perpendicular? Okay, that's what it's asking. Think about the fact that they told you in the beginning that AC was a line of symmetry. Well, we know what lines of symmetry also are. So, yeah, okay. Also, they gave us some other information up here. So think about it. Next, based on the line of symmetry, explain why angles ABC and ADC have the same measure. Okay, so ABC. Let me get rid of that last thing so we can look at these. ABC and ADC. Why are they the same measure? Right. Explain why. Right. That's the key piece here. Why is it that these angles are the same? Task 16. 3 line segments form the letter Z. A, B, C, D. Okay? Okay, great. Now what? Rotate the letter counterclockwise around the midpoint of segment BC. Now, midpoint means, you guessed it, the point in the middle, right? The point in the middle of segment BC. So the midpoint of BC, which would be somewhere around in here, okay, by 180 degrees. Describe the result. Okay, so what does this thing look like after you rotate it 180 degrees around a point that's right in the middle there? Next, task 18. There is a square, ABCS, inscribed in a circle with center D. We know what inscribed means. All the corners are touching the edge of the circle. We got a circle with a center of D. What is the smallest angle that we can rotate this square around D so that the image of A lands on B? How do we get A to land on B? What's the smallest amount that you could rotate the thing for that to happen? Task 19. Points A, B, C, and D are vertices, corners, of a square. Point E is inside the square. It doesn't say where inside the square. It just says that it's inside the square somewhere. Okay. So, explain how to tell whether point E is closer to A, B, C, or D. This one might be a little challenging. I recommend you grab a scratch piece of paper, draw a square, and try to figure it out. Like, use a pencil so you can move that mystery point E around. And how would you figure out what it's closer to? Other than say, well, it just looks like it's closer to blah, blah. No, come on. Do better than that. Think about the pizza shops. All right, task 20. Lines L and M are perpendicular. That's what this little doohickey down here says. Right? M is perpendicular to L. Here is line L. And here is line M, up and down. Okay. All right, that's the given information. Sometimes reflecting a point over M, right, there's line M. If we reflect a point over that, has the same effect as rotating the point 180 degrees using center P. Okay, so there's P, pivot point, right? Select all labeled points which have the same image for both transformations. In other words, if I reflect that image across line M, whatever point I choose, okay, will that land in the same place as if I reflected that original, if I rotated that original point around point P by 180 degrees. So which points would fall into that category, okay? So you're just going to have to kind of plug them through and go, okay, I'm going to try and reflect this one across line M and see where it ends up, and then I'm going to try and rotate that same original point. And if I land in the same spot, then great, that's one of the points that works. If it doesn't, then it doesn't work. All right, that's all you got to do. Next, 21. Here is triangle POG and some images of the triangle under a specific rotation. Okay, so here is the original. That says original underneath there. And then here are the 4 options for what happens to it. Okay, and there's some sort of rotation that happened. Okay, all right, so take a look at those. Now, it's not asking you to do anything yet. It's asking you to do something down here. It says, match the description of the rotation with the image of POG under that rotation. So in other words, which number of these, 1, 2, 3, or 4, okay, is this rotation, right? Rotating 60 degrees clockwise using point O as our center of rotation. So remember, there's point O, and here's our original. So we're rotating 60 degrees around point O. Remember, each one of these little tiny triangles is 60 degrees on every corner. So use that to your advantage, okay? Same thing here, right? Original, and then we rotate 120 degrees clockwise around point O. All right, again, there's point O, rotating clockwise 120 degrees. Which one of these is the one that is the result, okay? Same thing here, 24, read the directions here, figure out what's what, right? Notice that in each case here, they are giving you the center of rotation, the direction, and the number of degrees. The center of rotation, the direction, the number of degrees. The center of rotation, the direction, and the number of degrees. And I'm going to say it again. The center of rotation, the direction, and the number of degrees, okay? And in each case, it's a little bit different, so don't get tripped up. All you got to write is like 1, 2, 3, or 4 in these last ones. But figure it out, right? It's not that tough. Look carefully at the diagrams, bounce back and forth. You'll get it.